Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Fidectis. Go to www.fidectis.com for more information.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and with me is co-host Johan Oberg. Johan, how's it going this week?
Hi, Chris. Great to be on the show again another week. It's been a weird week here in Switzerland due to the fact that the kids are off, but that gave me an opportunity to have a few days off as well. How are you doing?
I'm doing well. I've been up in the mountains. I just got back from Flims. I was up there doing some mountain biking with my family for a few days and took the train home to get home in time to record this show today. So.
Perfect. Yeah, I was on the driving into Germany, but it was an interesting fact. You know, when you have your energy eye on as well as your marketing eye, I had the opportunity to take my son to Europark, which is a big amusement park in Germany. It's been on his wish list for a long, long time. So, okay, we'll do it. The funny thing is that when we get into the coolest ride of them all, my marketing eye kind of start twitching a little bit because you can see that the whole thing is sponsored, and it's not sponsored by anyone. It's actually sponsored by Nord Stream 2, which is quite of an interesting point, where it's powered by Nord Stream, but also the whole thing around how they put it down in the Baltic Sea, how it works, etc. So it was an interesting thing, and you know, I caught the eye of this and then bringing it back to the show, because I think it would be an interesting thing moving forward to see reasoning behind sponsoring a theme park ride with the exhibition part of it, not just a ride. But
so why would you do that? Just to get buy-in from the general population that Nord Stream is something good? Or like what marketing value is that?
You know what, I thought about this. We have on this show, you know, different ways of addressing the energy industry. We said it's a complex industry with not just producing the energy, but market the energy, but also the politics around it. And you know, without going in too much of Nord Stream 2, I think this is obviously one-ish part of it. You know, it's lobbying as well as it is the sponsorship. But it's a new way maybe of putting it through the kids. So they'll be the ones who start asking the questions. I don't know. But it's an interesting, kind of an interesting concept.
Well, I think that, you know, starting talking about kids, when I think about today's show, and we're going to have Energy Vault as our guest, and if you watch the videos and things they do, it reminds me of games and things I did as a kid. Because if you've ever stacked bricks up and ever played with like remote control cranes and done really cool things as a kid, this is a company you're probably going to want to go work at, because they have some badass technology that stacks things up taller than you can imagine. And it's like having a huge erector set or Lego set where you're building stuff, but yet it solves a problem for us in the environment and for the grid, right? And I'm really excited to get there. I mean, we got this episode pretty much lined up because our newest producer, when he first came on, about his second week on the show, he said, "Hey, Chris, can I have input into the content?" I'm like, "Yeah, our producers help pick the show." And he goes, "There's this really cool company in Switzerland. Any chance we could have them on?" And he sent me the link, and I'm like, these guys have some really cool stuff, and I want to find out more about it. And so, you know, I sent you the link. What is your first thing thinking about Johan?
But I agree with you, and I think we've had on the show before. We had a few shows ago. We had the mining storage. We've had a few. You know, we talked about a number of batteries and all these things that when we talk about grid scale storage, but I think this is fascinating, and I have a lot to learn about this because this is fairly new to me. But as you said, it looks pretty amazing. But what biggest question I always have is, where are we in terms of timelines regarding these larger scale energy storages? Because there's so much new technology coming out of them into the market now. And we have on the show, when we see in the news, but we're also at the same time now in, I wouldn't call it some kind of an energy crisis in Europe, because we cannot store the energy enough when it comes to renewables. So it's a little bit, I'm interested to hear the timelines a little bit. When do we have these available? When can we actually start using these fantastic technologies on scale so we can start really harmonizing and monetizing the renewable energy?
Well, I think we should ask our guest that. I mean, I think it's also interesting that this company is in Switzerland or has their prototype in Switzerland, because for gravity-fed energy, I mean, Switzerland's got a lot of hydro. We're in a country that's been doing this kind of stuff for a long time. So to see kind of a new take on that, it's interesting to hear the perspective of how it ended up here as well. So, but rather than us going back and forth like we always do, let's bring our guest on board and find out from him. So I'm going to introduce Marco Terruzzin. Marco, welcome to the program.
Nice to meet you, and thank you for having me.
Well, as you can tell, we're anticipating great things from the show. We're excited because you've got some really exciting technology. But before we go there, maybe you could tell us a little bit about your company and a little bit about yourself personally.
Yeah, the company is a very innovative company with a technology, as you said, that is addressing one of the biggest challenge that the energy sector and in general the economy is facing in these decades, the transition to a decarbonized economy. This is something that a scientist has been trying to address for decades, but very often it happened that only when the problem is self-evident, when people they face directly, the consequences of a problem, policy, regulators, and the economy in general start to address that problem directly. And Johan was talking about when this technology can be available, when these technologies are available. These technologies are available, and I think that we are at the verge of an inflection point, and we see already, the introduction of a massive amount of renewable energy that at the same time requires storage, because the electrical system for a century has been designed on the concept of just in time. And the lack of ability to store electricity has been a problem that kept the entire industry related to fossil fuel generation. Now that we understand that that is an issue and we need to migrate to a system with essentially no carbon, or at least less carbon intensive, storage is essential for this transition.
And so you're focused on storage. Now I've already been to your website, I've already seen videos and stuff, but maybe you should talk a little bit about what kind of storage you do and what you do for storage.
Yeah, this is very interesting. Maybe I tell you a little bit about myself, so you may and the audience can understand the perspective. I have been working in the utility sector for several years. I am a mechanical engineer, and this is kind of interesting because ultimately I'm taking advantage of some physics classes that I learned, the concept of potential energy back in high school and at the beginning of the years at the university. So that is interesting. I also have a PhD in energy economics. I studied in the US with my master in my MBA. And all of this is to say that energy is kind of a straightforward concept, but at the same time has a lot of nuances that it requires multiple angles to be implemented effectively. So technical consideration, market consideration, and also there is a social aspect because these technology, these investments are pretty massive, and they require support from politicians, regulators, and in general, the taxpayer and the ratepayers. I think that when a few years ago I used to work for a utility, at that time the big effort was to identify technologies with both the potential and the sustainability to be deployed on a large scale on multiple continents. And for sure, pumped hydro, and I had the pleasure also to live and work in Switzerland for 3 years, some years ago in Zurich, has been always the storage technology of reference to solve many problems represented by the just-in-time characteristic of the electricity sector. However, pumped hydro is related to special condition. You cannot have a pumped hydro plant everywhere in every city or everywhere you have additional load. So it has been a great resource for the first 100 years of this experience with electricity on large scale, but it has become also the bottleneck for the expansion. So we started to look into the most convenient technology 5-6 years ago, when I used to work in the utility sector. And at that time, batteries looked like the potential alternative. But even batteries, they start to have some evident limitation, both in terms of cost and also sustainability for their supply chain, materials coming from part of the world where there may be some issue, in the way that these materials are procured. And Energy Vault, I think, had a very simple intuition that was based on leveraging existing technology like a pumped hydro that are very well understood, and trying to convert a pumped hydro in a technology that could be located where the problem exists. And so it was an iterative process that started back in 2017. The company really took advantage of very creative minds. In particular, the CTO comes from Switzerland. So one more reason why we are having also this podcast with some tie back to the country, to Switzerland. And so with a few iterations, the company realized that there are few interesting things in using potential energy localized wherever the problem is evident. First, the round-trip efficiency, and that means essentially the efficiency that you have when you lift and lower the large masses, is pretty high. So the losses are not significant. And this is an excellent starting point, because that implies that the customer, the users of this technology, they are not affected by big losses. And that is important because ultimately the electricity market, it's a market where cost is essential to make a technology viable. The second aspect was related to the fact that using smart manufacturing process for the manufacturing of the bricks, these heavy masses that we lift and lower, was something possible. And thanks to partners in the material science, we have been able to define formulas for this material that allows us to have a very, very low cost for the manufacturing of these mobile masses. Everything else, after we were confident about these two elements, was a matter of using very sound engineering principle to put together what was the original design of the system that we call the EV1, and we have one of these systems installed in the southern part of Switzerland that has become kind of an iconic location, because for not only for the industry but also for schools, for people that want to educate themselves on how ultimately intuitive is the concept of storing electricity. So this was really the initial start of the company from the concept point of view, to sort out what was really the potential to solve the big problem with a technology that is highly scalable.
Can you guys hear him?
No.
Yeah.
Johan?
So
when we talk about technology, I think we're going to jump back a little bit into the technology later on, but just out of a curiosity question from a commercial side, you mentioned the word customer, and we have on this show discussed a lot of the stakeholders in the energy industry. But if we look at initially now, who are your customers? Who are the ones that you are? I can understand there's an investments part of is one part, but who is actually the customer? Because is this the utilities? Are these the RES? Is there a combination here? Can you?
Yeah, target customer, they are the logic consequences of the size of the problem. So by design and strategically, we wanted to design a technology that can help utilities and independent power producer to fix their problem. Of course, in the energy and electricity value chain, you do not have only utilities or independent power producer playing a role into the economy. For example, in the last 10 years, there has been this concept of a prosumer coming up like a relevant part of this equation, because just thinking about a rooftop solar panel for a single family home, they have become very popular and also very relevant for the distribution and consumption and generation of electricity. However, we believed that the time to market and the size of the technology that are needed and the projects that are needed to address this transition was essential. And if you put things in perspective, our project, they have an average size of 100 megawatt hours. So we are talking about $30–40 million, and rapidly, just following what the industry needs, utilities and independent power producers, we are approaching the gigawatt hour scale of our plant, because just looking at the size of a photovoltaic utility scale project, rapidly in the last 5–6 years, we went from here in North America, size around an average of 50 to 60 megawatts. And now it's a necessity to address this transition with size of photovoltaic plant around 300 megawatts. The largest plant in the Middle East, they are already above 1 gigawatt. And the same things are happening also in Australia. So if you want to shift, and I'm addressing now the pain point of this customer. If you want to help this customer, utilities, developers, to make electricity available not only when the sun is shining or the wind is blowing, you need to have the ability to store this electricity, for example, during the day when solar panels are working at their best, but providing this electricity when consumers, they need that. And very often, now more and more, there is a shift in the evening, more than during the day, because during the day, there is this kind of oversupply of production coming from PV generation. Wind is a little bit more constant, but the interesting part of this transition is the very low cost of solar panel, and they require very low cost of technology to store the electricity. And this is where I believe Energy Vault was a breakthrough. The ability to create something at large scale, a utility scale, that is really an enabler for the transition to a net zero economy with size of units that are in the range of 200–300 megawatt hour up to a gigawatt hour in region of the world like the Middle East, North America, and also Australia.
So I've seen, at least looking through your website a little bit, different investors that have invested in this. And I think there was one in the Middle East that caught my attention as well, that are betting in these kind of technologies. But I guess, where do these sit? So, I mean, these seem like they'd be pretty sizable to get the kind of power that you talked about. These are pretty big installations, correct? They're tall and big, or what kind of footprint do they take to meet that kind of requirement?
Yeah, so the technology, a gravity energy storage system, takes advantage of the force of gravity. So that is the factor that helped the design of this technology, and for example, help us to install systems with a technical life of 35 years, because lifting and lowering these large mobile masses create a very positive effect, that is essentially the lack of degradation during these exercise. Something that, for example, using different technology like batteries that are, a great contribution to this transition. I want to make very clear that it's not one technology against the other technology. It's really a collaboration of this technology, because the problem is so big that humankind, they really have to collaborate among, every potential development to enable this transition. However, coming back to your question, the force of gravity is, it is what it is everywhere on the planet. And so it's a math to calculate how much space we need. So on one side, there is this advantage that we can take, we can use established component. On the other side, we need to use a certain amount of space to deploy this technology for a long period of time. Let's say that if we compare our technology with a generation asset like solar, it's marginal, the amount of space that we need to deploy our systems, that they have a height around 120 meters. So it's significant, but that is required to bring these masses up, store the energy in the form of potential energy, and thereafter release, lowering these masses, release the energy store. So for sure, the technology doesn't fit a urban environment like downtown Manhattan, where other technology fit well that use case and that circumstances, that surrounding. But it's perfectly in line with what utilities and independent power producers they need when and where they have to deploy solar and wind, that very often happen in very remote areas where space is not an issue.
So even if it's space, we've seen from especially the wind parks that there are always, everyone wants wind, but they don't want it in their backyard, kind of a thing. When it comes to these 100-something meters, it's obviously visibly there. It's kind of difficult to get away from it. Out of curiosity, would you have the same thing if you built it down into the ground, almost like a shack or a mining? Would you have the same kind of technology but kind of hide it away?
Technically, that is possible, but we come to a cost consideration.
Yeah.
Digging a hole, it's something problematic, and we come here back to what the customer needs. The customer, and this is really essential to make sure that this transition is going to happen. We have an environmental problem that now I think is well understood, not only by specialists, but also by the public. It's something that happens every season, for example, in California, and this summer, it happened also in Europe, wildfire that has never happened before with that intensity. And are events that now are getting out of control, just to use an example. So utilities, they are driving this transition, adapting generation technology that are carbon-free, like solar, wind, and wherever is possible, hydropower plant. And their procurement is associated with buying technology that represent the best fit and the least cost in comparison with their procurement plan. So it's essential to take that into consideration to provide a technology that fits those requirements. So there are always possibility, to mitigate some aspect in a value proposition, like what you are saying, to dig a hole and hide part of the technology, but that will come at a higher cost. And so in a certain way, it's an impediment to this transition. At the same time, I just want to highlight a couple of things. We have been able to collect interest from every utility across the globe. We have been able rapidly to go from the foundation of the launch of the company in 2017 to today, with an announcement that we are going to become a public company. So this is a very interesting story. Just in 5 years, the soundness of the technology, the attractiveness of the economics, and also the characteristics of the product, they have been a great value proposition for utilities. And pairing gravity with a wind farm and solar, it's something that matches what not only the utility needs, but also in general the public has accepted and look at in a positive way, because what we have today are a coal power plant, gas power plant, that not only they aesthetically are debatable, but they are also creating pollution directly with CO2 and also indirectly with contamination of water and air nearby urban areas. So nothing is perfect, but the evidence that an investor like Saudi Aramco, SoftBank, utilities have invested in this company is clear that we are providing a very supportive solution to this transition.
So I've seen significant investment. I'm excited about your pending IPO or you're going public. That all makes sense. As we talked about in the introduction to the show, we're excited about the technology, but I think we're tap dancing around a little bit. I have a follow-up question, but it might make sense for you to tell a little bit about what your solution, maybe because we're on a podcast. It's like being on the radio, right? We need to describe what the solution is so the audience can picture it. So I think you've said things like gravity. You know, we understand that it's going to use gravity. You understand there's some sort of height requirement. I've divined all that out of the conversation. But if I were a listener that didn't know Energy Vault yet, I may not totally picture what you do. So maybe you could take a few minutes and describe it.
Absolutely, and this is probably also one of the most exciting part of this initiative and what we are doing. I would say that the way that Energy Vault developed the technology is probably the most intuitive way to store energy, because we are talking about using the force of gravity, and I think that everybody can quickly imagine that when you lift a mass, you are spending energy. It's difficult. You make an effort in doing that. Suppose that you want to ride with your bike to the top of a hill, and you are making an effort to do that. And in the parallel case, riding to the top of a hill is equivalent to charging from the grid, using electricity available from the grid, and store that electricity in the form of potential energy. That means having lifted this large volume of masses at height, so up to, for example, 100 meters, 120 meters. At that point, the beauty of our technology is that you can preserve that energy store at height without exposing to the leakage or consumption of electricity, because there is a natural decay or degradation of that form of energy. It's like a pumped hydro plant. When you store the water back into the upper stream reservoir, you have that volume stored there and available for whatever, as long as you want. So this is the first part of the process, charging. At that point, when you need that electricity back, and again, we are in a system where electricity is on demand. People, they go back home in the evening and they turn on their light. Now they start to charge their electric vehicle. You know, this is another very interesting transition that is happening within the larger transition of this energy market. There is also transportation that is moving towards the electrification, something very interesting that is putting additional pressure on the requirement and the need for this transition. So at that point, when there is the demand of electricity, our technology is relatively straightforward, because we are able to lower these mobile masses, and the electricity, the energy that was stored in the form of potential energy is converted in a kinetic energy, because these mobile masses start to accelerate down towards the lower part of the system. And the kinetic energy is moving a motor generator. And a motor generator, what does it do? It creates electricity. And so you have the electricity back into the system available at the time needed by the consumers.
And so you're moving blocks, it looked like in the video, some sort of mass, and you said there's a composite. They seem like cement big blocks is what they look like to the untrained eye. So what are these masses that you're moving?
Yeah, this is another, in my opinion, beautiful part of our technology and ultimately value proposition for customer and the economy in general. A lot of work that has been done at Energy Vault was to make sure that the essential component of our technology are eco-friendly. So first, we develop a strategic relationship with one of our initial partner and initial investors, Cemex, a company, is a worldwide company, one of the largest material company worldwide, and they have the R&D center in Switzerland. Again, one more time, Switzerland comes up as a very relevant country for the energy sector. And thanks to the collaboration with Cemex, we manufacture our bricks not using concrete at all. We use locally sourced soil, and this comes from the excavation of the foundation. We use a polymer that is a proprietary technology of Cemex, and we have exclusive utilization of that polymer for energy storage application. So this has created also a form of protection of our technology that we can implement and develop worldwide. And thanks to that polymer and one specific manufacturing process that is essentially a large pressing machine, we are able to create these large bricks. It's like, a big toy that kids can play with, apart the fact that it is really big, what we are manufacturing and the size of this equipment. So this was the initial step to enable the manufacturing of what we call eco bricks with a resistance, a mechanical features that is enough for what we need, because we don't need very strong, for example, concrete. So it was a combination of reducing the cost, targeting the right performance from the mechanical point of view, and making sure that from the environmental point of view, we can massively deploy this technology. So that was the first step. The second step was to understand which other need utilities they had. And working closely with utility, we discovered two very interesting things. So a problem of the past that we can address, and the problem that has emerged just recently with the wind farms. So the first problem is represented by the large volume of coal combustion residuals that has been stacked for many years in ponds nearby coal power plant. That is a big problem. It's an environmental problem because these residuals, they have a percentage of heavy metals that can percolate into the underground water. So that is an environmental problem, an environmental liability for the utilities, and a significant threat for the local population. So we have developed a relationship and a specific procedure to incorporate a large volume of this material into our eco-bricks. And so we have been able to provide an additional service and solution to our customer, not only providing them an excellent and economically attractive energy storage solution, but also a solution for an environmental problem that would have costed billions of dollars to be remediated. And so we take that material, we mix it up with a locally sourced soil, with the polymer, and we create bricks that essentially are not creating any percolation or leakage based on specific procedure and testing by Environmental Protection Agency in different parts of the world. The other element that I think is pretty cool is the fact that now the new industry, the wind industry, so the problem of today and the future, there has been the installation in the last 15, 20 years of many new wind farms. And the blades of this wind farm has not been designed to be recycled. You realize problem along the way. So currently in Europe, it's not anymore allowed to dump wind blades into landfill. And this created significant stress for companies like our customer, renewable energy developer, that initially they thought that that was completely an environmental asset like the wind blades, completely without any liability, and they had that problem. And so we signed a strategic partnership with one of the largest IPP worldwide, Enel Green Power. I'm very proud of this initiative because we have been able to provide a clear solution to the decommissioning and recycling of that material, extracting glass fibers from these wind blades and using these glass fiber in the manufacturing of our mobile masses. So, you know, these eco bricks represent a solution not only to be economically attractive, but also to solve environmental problems that otherwise would have created economic stress on the customers and environmental liability if not addressed.
That is just like great. I love the passion that's coming through as you describe your company and what you guys do. I just feel passion in everything you're saying. That's great. I'm enjoying the recycling element. That, you know, I was wondering, because when Luke and I were talking pre-show, I'm like, well, if they use cement adds greenhouse gases and things like that. I was really glad to hear that you're not contributing to the problem, that you're actually looking at solving problems, which leads me to the software. So how do you interact with your customers? So if you're balancing a grid or doing things like that, do you have, I mean, I think you're in California, which would tend to make me think you're at the software end of things these days, or where you may be sitting. What kind of software did you guys have to develop to make this all work?
Yeah, thank you for the question, because I think that if we do not talk about software, we do not provide the big picture, the complete picture of this technology. So Energy Vault has two important centers. One is in Switzerland, and that is really our development center that help us to bring to commercial operation the first unit that was commissioned in the middle of 2020. It was a challenging time because all of us remember, you know, that 2020 was the time when COVID struck very badly, in particular in Europe. But we have been able to finalize that project and demonstrate the performance of the unit. Thanks to our partner, thanks to our investors, and also thanks a lot to the passion of the people that have joined Energy Vault and that they are joining now, that we are accelerating with the deployments with a new project across the globe: Australia, Europe, North America, South Africa. And now coming back to your question, it's essential for a technology not only to work from, let's say, electromechanical point of view, that is, let's say, a necessary condition to be attractive and to be deployed. Okay, and that has to come with attractive economics, because again, utilities, they are buying things only if they are buying technologies and solutions only if they represent a best fit and the least cost. So that is essential. At the same time, we are in a world where Internet of Things, communication, dispatching, fulfilling specific use cases required by utilities and independent power producers, it's essential. So that was the second part of really, you know, the other side of the coin of our value proposition, that is essential and complementary to provide a fully dispatchable asset. So, you know, we have developed software not only to communicate properly with the grid, not only to enable our customer to make money out of our asset and making sure that they know when they have to charge, when they have to discharge, when they have to dispatch the asset, but we have also developed software that really helps to minimize operation and maintenance cost with a high computing power to maximize the efficiency of the process of lifting and lowering. So there is a lot of computing power to make sure that the efficiency is as high as possible. We use also computer vision software and predictive analytics to make sure that you know, the movement of these mobile masses is perfectly accurate. And so this combination of a very intuitive technology, solutions that are available on the market. We are talking about a motor generator, inverter, and in general components that can be bought directly from a large company like the GE of the world, the Siemens of the world. The combination of this technology, a proprietary design to combine and integrate all these components, and the software that is able to dispatch the entire system in an efficient way, has been really something unique that positions Energy Vault not only as a significant supplier of technology, basic technology, but also an enabler to help customer to dispatch these assets independently, and also in orchestration with the other assets that those customers, the utilities, they own, in a way that they can optimize their entire portfolio of generation and storage assets.
So in order to look at deployment around this, you mentioned the wind parks and the solar parks as a fantastic combination then to the storage solutions that you're offering, and then the software to kind of tie it all together. But there's also an investment part around this, where we see subsidies in some countries on renewable energy, but also moving a lot now to the PPA, especially a long-term PPA in terms of building a new solar park or a new wind park. Is this something that you, in terms of financing, in terms of deployment of your technology, is this something also that you're looking into, maybe together with the wind park, to see can we combine the storage solutions as well as the wind park in the long-term PPA, or how is this then financially done from your side?
Yeah, great question. So when we talk about the financing part of our technology, I would address two considerations. The first is the way that the company wanted, that Energy Vault wanted to build up its own balance sheet to make sure that we can work and we can be a reliable partner for big companies like Enel Green Power, like Saudi Aramco, like EDF, because it's at this point we are talking about hundreds of millions of dollars of investment. A PV farm of 500 megawatts is easily 200 million plus. And if you want to attach storage, that is more or less the ticket, equivalent ticket for those investments. So it was a necessity for Energy Vault to grow rapidly, not only with the technology, but also as a company. And for this reason, we made a decision to accelerate the path to become a public company. So this is one part of the equation. On the other side, I would say the viability of what we do is directly related to the competitiveness of generation assets like solar and wind. And now we know that solar by itself is the cheapest form of generation of electricity. We are talking about something that is below $20 per megawatt hour. So well below the average cost of generation of a coal power plant or a gas power plant. The problem is that you do not have, obviously, sun overnight. So that cost has to be augmented in a certain way. You need to add an additional cost for the storage. And we see that it's happening regularly that load service entities are asking not only for a renewable generation asset, but they are asking also for the dispatchability of this asset. That means that the developer has to add a form of storage. So it's part of embedding, incorporating in the cost of the PPA, the additional cost of the storage. So the necessity is there. For a customer, the decision is which storage will represent the lowest possible incremental cost to fulfill the job. So how can I make solar dispatchable at the lowest possible cost? And this is where our value proposition at scale and with our economics becomes essential to enable and augment the entire number of technologies that are helping the transition. So it's on one side, again, is our balance sheet. On the other side is being best in class in helping our customer to minimize their total procurement cost.
So understand the cost rolling in, and you said something earlier that caught my attention. You mentioned projects just about every continent, mostly, or many continents. I think you mentioned projects on. So your go-to-market, and I've seen tremendous amounts of money go in. You're going public to raise more money to hit the scale, to hit the economies of scale. How do you deploy these large scales? Do you have contractors that are partners to bring these out? I mean, these are huge projects, right? These are big construction sites that take a lot of engineering and building, I'd imagine. So how do you scale this out across those size companies you mentioned all at the same time in a hurry?
Excellent question, because if you have a good technology, if you have a good ideas, a good plan, but ultimately there is no effective go-to-market and a delivery strategy, all of that will be not effective, clear. So this was really part of the design and the strategy around the characteristic of the technology. So try to imagine in this way. Energy Vault technology, and we recently launched the new product called EVX. It's essentially a building. Wherever a building can be built, we can build our technology. So this creates a lot of positive synergies and implications, because we can leverage existing infrastructure, existing supply chain in the real estate industry. And everywhere, in every continent, you have large EPC companies. They're very familiar with the construction of large real estate infrastructure. So we have properly adjusted the relationship between what is done locally. For example, we do not need a gigafactory. We don't have to spend the money to build a gigafactory and also adjust the logistics to ship batteries or components from one part of the world to another continent. We take advantage of existing supply chain, existing partner, EPC partner in Australia, in Europe, here in North America, and the remaining part of the component, they can be sourced locally, because we are talking about a motor generator that, for example, General Electric or Siemens or ABB, they have a manufacturing location across the globe, and they already have a very well-established logistic chain, logistic flow of operation. So that was properly thought to make sure that we are not running in any bottleneck. We are not running into, for example, spike of price in raw material. We are insisting on a supply chain that is there, is 100 years that is there. It is essentially the large real estate supply chain that we leverage in terms of skills and availability on multiple continents.
So, and it sounded like from this conversation that you're a big proponent, all renewable is entertaining to you, but it sounds like the near-term projects are more solar-based than wind-based. Is that a takeaway from our conversation?
They are both. They are both, because ultimately we are a kind of agnostic in terms of renewable energy. For us, it's a form of an electron in a certain way doesn't have a color. It has to be just stored. And for this reason, it depends on what is the customer need. However, I have to say that historically, you're right. Until now, solar has been a much better fit in terms of use case to be paired with energy storage than wind. And the reason is kind of straightforward. Solar, the solar path is more predictable than a wind behavior. In these terms, you may have sometimes 2 or 3 days of unexpected low wind situation. So at that point, the amount of storage that you need to create a dispatchable asset with wind, it's big. So currently, it's a matter of low-hanging fruit. The industry is trying to solve the problem with a lowest cost opportunity that is represented today by solar. However, it's just a matter of time with a cost reduction of storage technology. The intrinsic cost reduction of renewable energy technologies, storage in one form or another will be adapted by all of these generation assets, because ultimately the intermittency nature of those assets is there, and the requirement, the need to make those assets dispatchable is essential, again, to transition to something that is able to provide electricity on demand.
Which I think sounds fantastic, and I thought this was a really, really interesting insight. I know we're coming up to time, but just my reflections a little bit in terms of what I thought around this. I think it's fascinating. We had on the show before when we went underground, now we go overground. What I think is really, really interesting in terms of the scale of the storage is that you're using, if I understand it correctly, the existing technologies and a lot of the existing partners there's already on the market, which means, going back to my questions in the beginning, how do we scale on this one? Well, it's actually a new way of doing it, but with an old technology, which means that we have cut a lot of those parts, which I thought was really, really interesting and really, thankful for getting that input, because that was one of my biggest question and part introducing the show. Listening to you as well, I couldn't help myself of thinking of Isaac Newton on this side of my brain and my fellow Danish friends of the Lego on the left-hand side here, with the blocks coming up and down on gravity. So I'm still visualizing the whole concept. But I thought it was really, really interesting to have you on the show. I thought this was, really, really interesting. And I wish I would see it in live one day, because it would be really cool to see it. So I probably have 1,000 more questions, but I know we're running out of time. So thank you very much for attending.
But,
Chris,
but
do you have a final question?
I
know you have one more.
I always have one more.
For the last one. I know. I'll hand it over to you.
And so the technology sounds exciting. It's got so much promise. It's on the front edge here of where it's going. You're getting the funding to get the scale you need. 5 years from now, where are you?
Oh, the company, thank you for the question, because that was one of the fundamental reason why I joined personally Energy Vault. Energy Vault mission is to identify, develop, and bring to the market the most sustainable and economically attractive energy storage solution to enable the transition. So Energy Vault is dedicated to the development of a portfolio of technology. Now we are not only, and we are very focused on deploying the first technology, gravity, to make sure that we are accelerating the transition. 5 years from now, Energy Vault will be a significant player in helping utilities, not only with our fundamental technology, but also with the software platform that we are expanding every day to facilitate the dispatching of all these assets. And we will do our best to introduce additional technology, because Energy Vault is the energy storage company, to further accelerate the transition and help the system to maintain sustainability standard, safety standard, and providing the lowest possible cost to enable very low cost of electricity and available for everybody.
Well, that's great promise. I'm looking forward to it. I hope you will let us check back with you in a year or so to see how you've progressed. I'd love to hear the story as it develops. Thank you so much for being a guest on the show. I'm sure our audience enjoyed it as much as Johan and I did, and I can see our producer in the corner there. He's smiling the whole time. He's loving the content as well. Marco, thank you so much for sharing.
It's a pleasure. Thank you for having me.
For our audience, once again, you spent another hour listening to Insider's Guide to Energy. If you've enjoyed the content today, enjoyed the show, please continue to send comments in. We'd love to get your feedback. Share the episode with your friends. And if you haven't subscribed yet, please don't forget to subscribe. And check us out on the YouTube channel as well. Another way to see how the sausage is made and see us making these podcasts behind the scenes. So we look forward to seeing you again next week. Thank you.